Hey guys, today we are talking about graphing and translating square root functions. Now, a square root function is different than other functions we've seen because it is really kind of only one-sided. Whenever we talk about a square root, we can see what our graph looks like here. It just starts in the center at its vertex and it just goes off one way. Now, the reason this happens is because it's a square root, and we can't have the square root of negative numbers. And so, like we learned yesterday, the square root is the inverse of a parabola of a quadratic. But you'll notice we were only working with half of it. That's why we had to do those restrictions on some of our graphs yesterday. But here's kind of how it works, okay? We have x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. If x is 2, the square root of 4 is 2. And if x is 9, the square root is 3. That's why it kind of keeps getting flatter and flatter as we go out. Now, technically, it's going to keep going out to the right for forever, and it's also going to keep going up for forever. That's why my domain is x is greater than or equal to 0, and why my range is y is greater than or equal to 0. But notice this, there's no axis of symmetry, but everything else is the same. We're going to find what our vertex is, we're going to figure out which way our graph is going, and then we're going to find some points on that graph, okay? So let's start off and let's take a look at our transformations that we can have. They're the same as what they've always been, but let's take a look here. Vertical, stretch, and compress. In my equation, remember we have our equation that everything goes with here. All right, and that equation is our y equals a times the square root of b, x minus h, and then plus k there on the end. So anyways, with our vertical, stretch, or compress, that is my a. Vertical reflection, that's when we have a negative a. A horizontal stretch and compress, this is something we haven't seen a lot of, but that's my b. That's going to be my number inside the square root. A horizontal stretch or a horizontal compress means that my graph is going to go out wider, quicker. It's going to horizontally stretch or horizontally compress. If it's a whole number, like 3, it's going to compress. So it's kind of backwards the way a is. And if it's a fraction, it's going to stretch. So like I said, it's kind of backwards, but we'll talk more about that later. But this is my b. And a horizontal reflection. Now, we haven't really had to worry about horizontal reflections much. But a horizontal reflection, if we start here, a horizontal reflection would be it going out here, my graph that is. And so if we see that, it's going to be my opposite. Now, a horizontal shift, we know what that is. That's just my h, right? And so my h is a liar, but that's going to be my left and right. And then my k is going to be my up and down shift. Don't worry, we'll get a lot of practice with this, okay? So let's go ahead and let's talk about some transformations. Okay, so transformation number 1 here. We can shift 3 units to the left and have a vertical shift 6 units down. So shift 3 units to the left. That's going to correspond with h. That's a horizontal shift, shifting 3 units to the left. So for this one, my h, excuse me, my staying thing always does that sometimes. All right, so we're going to get h equals -3. Okay, so we're 3 units to the left. And then a vertical shift 6 units down. So we're going to go down 6 units. That means we're going to have a vertical shift down 6. Okay, so h is -3, k is -6, so we could go to the left. We're going to go to the left 3 and down 6. Now let's write our equation. Okay, so here's what we're working with right here. F of x equals a times the square root of b times x minus h plus k. Each one of these affects my graph a different way, right? A, B, H, and K. So H and K we decided was this, and we're A and B we don't have to worry about at all because it doesn't mention any changes for that. So we're just going to write my equation here. I'm going to write f of x equals nothing really for A, the square root of nothing for B, x minus my h. Remember, when h is inside, it's a liar. So since we're minusing that -3, we're actually going to add 3, and then my k on the end is going to be a -6. All right, so there's my first written out equation. Okay, so look at number 2. Number 2 says horizontally reflect and vertical stretch by 3. All right, so this is our new one. This is our new thing we're learning about. Horizontally reflect. What letter does that correspond with? Well, that's with my B. Horizontal reflection is goes with my B, so that's going to be, we're going to have a negative inside of my square root. So we'll have a negative B. Next, we have a vertical stretch by 3. Vertical stretch by 3, that's my A, and it's not backwards or a lie or anything, so that one's just going to be A equals 3. Okay, so we're going to have f of x equals my A of 3 times the square root of opposite B. So we're going to have a negative B and an x, and then it doesn't say anything about my h or my k, so we can just stop right there. F of x equals 3 times the square root of negative x. Oops. Negative x, and that's going to be my equation. Okay, take a look here now at number 3. So number 3, we're going to have a vertical compressed by a factor of 1/2. Now vertical compressed, that's again my A. And so that means that my A here is going to be 1/2. It's not backwards. B is backwards. A is not. Okay. Then we're going to shift 3 units right. So if we're shifting 3 units right, that's going to mean my H is 3. And then lastly, we're going to shift 2 units up, so that means my K is 2. So let's write this out here. I'm just going to use Y instead of F of X. Remember, we can use either. So I'm going to say Y equals 1/2 times, well, not times, we're going to do a square root, 1/2, and then a square root of x minus my h. There's no b here, so it's just going to be x minus 3, and then plus my k, and my k is 2. So there is my equation with these transformations. In our last transformations problem, we're going to reflect vertically, have a horizontal stretch by a factor of 1/2, and have a vertical shift down 5. So reflect vertically. If I reflect vertically, that means we're going to have a negative A. If I have a horizontal stretch by a factor of 2. Now remember, my B is backwards. And so if I have a horizontal stretch by a factor of 2, we're actually going to have a 1/2 for B. Okay? It's in there hanging out with the X along with H, and so it's a little funky. So it's backwards. So to have that horizontal stretch by a factor of 2, that's just going to be the same thing as saying B equals 1/2. Okay? So B equals 1/2, and then we have a vertical shift down 5. So that's our last one. Vertical shift down 5. That's going to mean my K is going to be negative 5. So let's write our equation. We're going to go F of X equals negative A. So we're going to have a negative. We'll have a square root. B is going to be 1/2 times my X. There's not going to be any K, and so I'm just going to have a minus 5 there at the end. All right? So just breaking it down piece by piece. Okay, so now let's actually graph. So let's take this square root. F of x equals the square root of x plus 4 minus 2. Okay? Square root of x plus 4 minus 2. And we're going to take that graph, we're going to put it here. Remember, my parent function looks like this. Okay? It's kind of what my parent function looks like. It's just going to go out to the right. So we're going to have a graph that looks very similar to that. But let's go ahead, let's think, where's my graph going to shift to? Because that's going to play a big part in this. So we're going to have a, we're going to label my h and k. Look here, my h is going to be negative 4, and my k is going to be 2. That means that my center, not my center, my vertex for this graph, is going to be at negative 4, 2. So my new graph, we're going to go out 4, down 2, and that's going to be my vertex. And then there's no A or B, so it's not going to stretch or compress at all, so we're going to kind of have the same format. All right. So let's go ahead. Let's draw a table and label my x and y here. Okay. So for this, my x, we're going to start at the center. So we're going to have -4 as my starting point. And I know I have a point at -4, 2. We've already put that out there. Then we're going to go one to the right at -3. And we're going to go up to 1. So we're going to have a point at -3, 1. If we plug -3 in, look, -3 plus 4 is 1. Square root of 1 is 1. 1 minus 2 is, I apologize, -1. And this should, of course, be a -2. Look at me making these mistakes. Look, that k should be a negative. That k should be a negative. Apologize for the mistake, guys. So yeah, it should all be negative. We're at -4, -2. So if you're screaming at me that I messed up, I caught it. All right, so -3, -1. Then we are going to go all the way out to 0. Okay? And so we're going to be at 0, 0. Just trust me on some of these. Just know that I'm a math teacher. I know what we're doing. So we're going to go at 0, 0. So that shows me where my graph goes. So we can kind of ignore my parent function now. And my graph is just going to look like this. We're going to start here. And we're going to go out this direction, like so. Okay? All right. So now, let's go ahead. Let's find my vertex graph. Okay? Let's find my vertex of this. Sorry, my apologies. We're going to try to find the inverse. Now, the inverse graph of this, we know is going to be a quadratic, right? In fact, it's going to be a quadratic because we can switch x and y on everything, right? So let's take this original one, and we can switch x and y. This f of x can become my x, and this x in here can become my y. And so now we can just work this out. We can add 2 to both sides, and it's just like what we did yesterday. We're going to add 2 here, add 2 here. We're going to have x plus 2 equals the square root of y plus 4. I can square both sides. We're going to have y plus 4 equals x plus 2 squared. And last but not least, we can minus this 4 over here. So I'm creating a new inverse equation. I'm going to take this and I'm going to rewrite it over here a little bit better. So I'm going to rewrite it as f of f to the -1 of x, because that's my inverse, equals x plus 2 squared minus 4. So this is my inverse, and it's going to be the exact inverse, but we're going to have to put a stipulation on this. This is going to be the inverse when x is greater than or equal to my k up here, -2. Okay, and you'll see why that is in a second. Let's take this and let's find the inverse points. And remember, an inverse is just switching the x and y, so I can just take these points and I can switch them to do my new graph. Okay, so I can switch these. We're going to have a point at -2, -4. We're going to have a point at -1, -3. And we're going to have a point at 0, 0. So I know all of that is true. So we can put those here. And it's going to look like this graph. It's going to open up like a quadratic. So we're going to go -2, -4 down here. We're going to have a point at -1. Oh, I overcounted. That's -5. I'm sorry. All right, so -2, -1, 2, 3, 4 right there. We're going to have -1, -3. And we're also going to still have a point at 0, 0. Okay, so it's going to start here. It's going to go up. And so you can see how these two are vertexes of each other. It switches perfectly. And normally in a quadratic, I would have a part of my graph going up this way. But we had to put the stipulation on here because this only has one side. So that part there doesn't actually count. Okay? So now this final thing, let's talk about the domain and range of each piece. The domain and range of my original function, well, it's going to be, my domain is my left and right, my x value, right? And so it's going to be greater than -4. So we're going to have x is greater than or equal to -4, or we can draw it like this, negative 4 to infinity. My other one, okay, the range, it's going to start at negative 2, and it's going to technically go up for forever. So it's going to be y is greater than or equal to negative 2, or negative 2 to infinity. Then my inverse domain and range. The inverse domain is going to be, my inverse domain is that we are going to start at negative 2, and we're going to go to the right for forever. So it's going to be x is greater than or equal to negative 2, and negative 2 to infinity. The other way we can write that is our range starts at negative 4 and goes up for infinity. So it's going to be y is greater than or equal to negative 4, or negative 4 to infinity. Okay? So notice our domain and ranges are also opposite, right? Those numbers are also flipped. So everything about my inverses are just backwards. So we have our square roots graph like that, and then I have my inverse graph that opens like that. That is a quadratic, but it's really only half of a quadratic. Okay, so now let's take a look at our last graph here. So number 6, we're going to sketch this guy. We have f of x equals 1/4 x squared, and we're going to say when x is less than or equal to 0. So let's go ahead and graph this. Because of this 1/4, I know that I'm going to have a compression, right? So let's find some points for this. Let's think of some points that can go in here. Well, first off, we're going to label my x and my y, and we're going to have a point at 0, 0. We have a point at 0, 0. And we're going to pick points that are all less than or equal to 0. Okay, that's really important. All those points that are less than or equal to 0. So let's pick a point at negative 2. Because I know if we go negative 2 squared, that's 4. 4 times a fourth is 1. Then let's pick a point at negative 4. Negative 4 squared is 16. 16 times 4 is 4. So that kind of gives us an idea of where we're at. So let's put all these points on here. So we're going to have a point at 0, 0. We're going to have a point at negative 2, 1. We're going to have a point at negative 4, 4. And so this is going to be kind of a sloping quadratic, and it's everything less than. So we're not, our other side would be like over here, but we're not going to graph that other side. We only care about the less than side. Okay, so if we only care about the less than side, after we do our square root, we're going to have a minus. So let's go ahead, let's solve for our inverse. So to solve for our inverse, we're going to switch my x and y. We're going to get rid of this fraction by multiplying both sides by 4, right? Get rid of this fraction, we're going to multiply this side by 4 and this side by 4. So we're going to have 4x equals y squared. Then we're going to square root both sides. Square root this side, square root this side. We're going to have y equals the square root of 4x. That's the same thing as having a b of 4x. So we're going to have a stretch horizontally for this one too. So let's go ahead, let's find some points. Now remember, our points on here are just going to be, my apologies, are just going to be the inverse, right? So we're going to have my x to the negative 1 and my y to the negative 1, and we just flip these. So we're going to have a point at 4, negative 4. We're going to have a point at 1, negative 2. We're going to have a point at 0, 0. So we can put those points on here. We have a point at 1, 2, 3, 4, down 1, 2, 3, 4. There we go. We can have a point at 1, negative 2. We have a point at 0, 0. Oh man, we can really see like how we found the inverses, right? It's just going to open up like this. And it's just a perfect reflection of that other one across that diagonal. Okay, so that is indeed my inverse, but I forgot one thing. It should be a negative. So whenever I rewrite this, we're going to go f to the negative 1 of x equals negative square roots of 4x. Okay, and since we have a negative on the outside, it's going to be that vertical reflection. Okay, now let's talk about the domains and the range. So for my f of x, my domain is it's going to open out to the left. So we're going to say x is less than or equal to 0. In other words, we're going to be like, okay, it's going to be negative infinity to 0 for my domain. For my range, it's going to be everything greater than 0 because it's going up. So it's going out to the left and it's going up. So for my range, we're going to go y is greater than or equal to 0 or 0 to infinity. And then we know that those are going to be flipped for these over here, right? So we're going to have my domain here. It's going to go out to the right for forever. So we're going to go x is greater than or equal to 0 or 0 to infinity. And then my range, it's going to go down for forever. So we're going to have y is less than or equal to 0 or negative infinity to 0. Okay? Last but not least, let's answer this question. Why must the domain be restricted? Well, the domain must be restricted because a square root only really has half of that graph, only half of the parabola. So we have to restrict the domain to find the inverse in my squared functions. Okay? All right, so I'm going to write that out because I'm going to make it real simple. Because we only have half the graph. Okay? Real simple. Okay. Listen, this is the last lesson. I understand it's kind of a doozy. Just try your best in the homework, but I want you to focus on studying for your semester exam next week. You'll see the review in Canvas. Take care of that review. That way you'll be ready for what comes next. Okay? We're all going to be taking that semester exam next week. All right, guys, hope you have a great rest of your day and a good weekend, and good luck on your semester exam next week.